Hello. So today I want to talk about a few pulley problems. Alright. So the first problem is a pulley is over here. Alright. We want to find the tension along the string and the acceleration of the block. Because if this block goes downwards, this block will go upwards and they will have the same acceleration. Alright. So let's just draw all the forces acting on both of the blocks. Alright. They both have tension over here and they both have gravity. Alright. So we know that the acceleration in this side is upwards, right? So that means that the tension is greater than the gravitational force, right? Because it is accelerating upwards. So that means that tension minus 2 mg, which is the gravitational force on the 2m block, is equal to 2ma. Over here it is accelerating downwards. Alright, so that means that the gravitational pull is greater than the tension. So that means 3 mg minus t is equal to 3 ma. Alright, so let's just call this equation 1 and this one equation 2. So if we add 1 and 2, we see that these two tensions cancel out. So 3 mg minus 2 mg is equal to 2 ma plus 3 ma, or in this case mg is equal to 2 plus 3 is equal to 5 ma. Alright, 5 ma. Alright, so that means a is equal to mg upon 5m. Over here it is equal to g by 5. Alright, so the acceleration is equal to g by 5. Alright, now we have the acceleration over here. So acceleration over here is g by 5 or 10 by 5, which is 2 meters per second square. Alright, now the tension is equal to, if we see in equation 1, the tension is equal to 2 times m times a plus g, right? Hence 2m, a is 2 meter per second square, plus g, which is 10. So this is 12. So this is 24 m Newton. Oh. Alright. So the second question is that on a cliff there is a pulley over here, and this over here is frictionless. Alright, over here a block is attached. This block is of m. This block is of 2m mass, and this block is of m mass. Then do you think that this block will go this side? Will it go? And do you think that this block will go this side? Well, Sam, no, because this is heavier, right? So this will just stay where it is. But no, that's wrong, because it is frictionless, right? The surface is frictionless. So even if you put an elephant on this side and you put a matchstick on this side, the matchstick will still pull the elephant downwards. Alright. So that means that this is accelerating this side and this is accelerating downwards. Alright. Now the 2m block obviously has normal force acting on it, but let's just neglect that as it is equal to 0. I mean, like the normal force is equal to 2 mg. Alright, so we can just neglect that. So let's just draw the let's just write the Newton's second law of motion. So tension over here and tension over here. So tension is equal to mass times acceleration, so 2ma. Alright, this is the first equation, and over here we know that there is an mg acting, and mg is greater than t since it is accelerating downwards. So that means mg minus t is equal to ma, and this is the second equation. Now we add the first and the second equation. We get, now the t's cancel out again, so mg is equal to 2ma plus ma. So mg is equal to 3ma. A is equal to mg upon 3m, which is equal to g by 3. Alright, so the acceleration is equal to g by 3. Alright, now the tension, if we take the first equation, tension is equal to 2ma, right? 2 times m times a, which is g by 3. Alright, so it is equal to 2mg by 3. Alright, now let's move on to the third question. This one is a little bit tricky. Alright, so there are two pulleys now in this case. One has 2m over here m, and over here 3m. Alright, so now I'm guessing that the acceleration is downwards over here. So this block will be pulling these two blocks. Alright, I'm guessing. Alright, so that means this block will go this side and this block will go this side. Alright, so that means that there is gravity acting on this. Alright, so the strings over here, let's just the strings over here are different, right? This string is different than this string right here. So let's just call this T1 and let's call this T2. Alright, I know that 3mg is greater than T2, 2mg is less than T1, and over here T2 is greater than T1 as it is accelerating. Alright, so let's draw the Newton's second law of motion. Alright, for the 2m block, T1 minus 2mg is equal to 2ma. Alright, this is the first equation. Alright, then T2 minus T1 is equal to 2ma. Ma. This is the second equation. Alright, and the third equation is 3mg minus T2 is equal to 3ma, and this is the third equation. Alright, if we add 1, 2 and 3, then we can see that over here there is positive T1, or here there is negative T1, or here there is positive T2, and over here there is negative T2. Alright, so these cancel out. So 3mg minus 2mg is equal to 2ma plus 3ma is 5ma plus 1 is 6ma. So 6ma. Alright, and over here this is mg is equal to 6ma. So a is equal to gets cancelled, g by 6. Alright, and let me just check the answer. Yes, the answer is g by 6. Alright, they have not given the answer for tension. Alright, but we'll just calculate tension for fun. Alright, so tension T1 is equal to, so here T1 is equal to 2m times a plus g. So g in bracket 1 plus 1 by 6. Alright, I think I'm going a little too fast. So m, acceleration over here is a plus g, right? So g by 6 plus g, right? Since it is tension is equal to 2m times a plus g. Alright, so that means it is equal to 2mg times 1 plus 1 by 6, and this is equal to 7 by 6. So 14 mg by 6. 14 mg by 6. This is 7, this is 3. So it is equal to 7 mg upon 3. Alright, which is T1. Alright, so T1 and T2. Alright, so this is 7 mg upon 3. Alright, and T2 is equal to 3mg minus 3ma. Alright, 3mg minus 3ma. Alright, which is equal to 3mg 1 minus 1 by 6, which is 5 by 6. Alright, so 3 2s are 6. This is 5 mg by 2. So T2 is equal to 5 mg by 2. 5 mg by 2. Alright, so we have the three values over here. Alright, so let's move on to the third question. So it says that in a pulley, alright, there is 2m on this side and a block m on this side and another block 3m on this side. Alright, and now I'm guessing that acceleration is upwards over here and acceleration is downwards over here. Alright, so we want to find a, T1 and T2. Let's call this T1. Alright, and let's call this T2. Alright, so over here, this is a very good question. So over here, let's just draw the second law of motion for this. So over here there is 2mg, over here there is 3mg, and over here there is mg. Alright, so the first equation is T1 minus 2mg is equal to 2ma. Alright, this is the first equation. Alright, let me just actually move this to this side. Alright, and now Why is that happening? Alright, so for the second one, for the M block, not the 3M, the M block, there are two forces, right? So mg and T2 are causing it to accelerate downwards. Alright, because this 3M is also acting on this M with a tension of T2. So that means that T2 plus mg minus T1 is equal to ma. Alright, now the third one, the 3M block, is 3mg minus T2. Alright, so 3mg minus T2 is equal to 3ma. Alright, and if you see in this, all these three equations, if we add them up, then the t's get cancelled. Alright, so we're left with 3mg plus mg minus 2mg is equal to 3 plus 2 is 5, 6ma. Alright, 4mg minus 2, so 2mg is equal to 6ma. 2 3s are 6, m gets cancelled, a is equal to g by 3. Alright, so this is g by 3. Alright, now T1 is equal to 2mg times 1 plus 1 by 3, which is 4 by 3. Alright, so T1 is equal to 8mg by 3. Alright, T2 is equal to 3mg minus ma, so that means 3mg 1 minus 1 by 3, which is 2 by 3. 3 gets cancelled, so it is equal to 2mg. Alright, so this is equal to 2mg. Right, we have the three values. Alright, now there is just one more question left. Alright, so the last question, this is, alright, let's just screw it. I'm not writing the question numbers. So the last question states that on an inclined plane, a wedge, alright, of an angle of 30 degrees, there is a pulley, alright. On this side there is M, and on this side there is 4M. Alright, so I'm guessing that this side is the acceleration, alright, like this. So that means that, and we know that over here it's very important to know that this is equal to g sine 30, so it is 4mg sine 30 degrees. Alright, it is always the sine, so it's pulling this side, but it's actually like the gravity is pulling this side, so it is the sine of that angle. If you kind of makes sense, it kind of makes sense. So for example, if I pull a block like this, alright, so it's actually pulling, it's the same as pulling like this from this side, so it is just cos of this angle. Alright, just like that, this is the sine of 30 degrees. Alright, and this, so this is tension, and this is mg. Alright, so the first equation is T minus mg is equal to ma. This is the first equation, and over here 4mg sine 30 degrees minus T is equal to 4ma. Right, this is the second equation. If we add them, then 4mg sine 30, which is just 1 by 2, so I can just write this as 2mg, alright, minus mg is equal to 5ma. Alright, this is mg equal to 5ma. This is 5ma. Alright, g is 10, this is 2, this gets cancelled. A is equal to 2 meters per second square. Alright, or just G by 5. Alright, so A is equal to 2 meters per second square, or G by 5. Alright, and now we want to find tension. So which is easier to find tension with? Is it equation 1 or 2? It's obvious it's equation 1, right? So T is equal to M times G plus A. So M times 10 plus 2, which is 12. So tension is equal to 12M. So 12M newtons. Alright, these are the two values. And this is it for this video. Thanks for watching. Bye.